Hello, hi, welcome back. I've been doing a bit of research or bit of play around with the large language models and using Ollama as a tool. I've been running multiple large language models on my Mac. Now, it's a bit of a challenge while working with these large language models to interact with them using the terminal. If you have seen one of the earlier videos, I had shown how to set up Llama 3.1 as the offline large language model, and since then I've used other models like V3 and also the Mistral. Now, all these large language models, we can interact with them using Ollama. While I was interacting with them using the terminal, I can still get a response from them, but it's a bit of a cumbersome process to work with them on the terminal. Wouldn't it be great if we had a user interface like the chatGPT where we could post a question and we get the response back? Instead of building that user interface ourselves, I found out an open source project which is called as the Open Web UI. It was initially called as the Open Ollama, I think, when it was working only with Ollama, but now they have extended it to the other large language models. And I can use this to interact with the large language models. So to use the Open Web UI, you can in fact head over to the website of this project and get to know more details about them, how to get started, what are the different features of this. The easiest way to work with this, in my opinion, is to use the Docker image available as part of this Open Web UI. And that is what I'm going to demonstrate in this video today. So let's get started. First thing, I'm going to run a Docker run command here to get the Open Web UI running. There is an image provided by the Open Web UI project, and I use these different parameters to run this particular image as a Docker image. It's also been some time since I did a video on Docker, so I think this is a good combination of showing how to use a UI and also show some of the features of Docker. I'm going to use the Docker run command with the detach flag, and I'm going to use this additional parameters to specify some settings related to the Docker. First one is the publish, where I'm going to do the port mapping for 8080 port, which is used internally by the Open Web UI container or image to map it to port 3000 on my local machine. I'm also using the add host option to specify that I'm referring to the internal Docker host where this particular image of Open Web UI or container is going to be running inside the Docker host. So I specify host.docker.internal as the host gateway, and then I also do the volume mapping so that any configuration that we set for the Open Web UI, it does not get lost if the container is restarted, and we set the restart policy as always. And with that, I specify the name of the image, which is the ghcr.io. It's coming from the GitHub repository, and we take this as the name of Open Web UI, and we are using the main tag for the image. Now we can go and verify this image is running using the Docker desktop UI. Under the images, I have already downloaded this image because it is about 4.45 or almost 4.5 GB in size. And once the container is running, we can see that it's been started about 30 seconds ago and it's running on port 3000. We can click directly on that user interface within the Docker desktop, or we can open the UI by going to the browser and hitting the localhost 3000 as the URL. Initially, it will ask us to create an account, and there is a setting where we can disable the authorization. But for the purpose of this demo, I will go and sign up here. This will become my admin account, and when I say create account, it says I've already logged in. And in here, you can see that automatically it gives us this user interface, which is quite similar to that of the ChatGPT. On the left, we have this workspace option, new chat, and also some settings. And then we have the option to send a query or the question here. And we also get some default prompts, and it starts with a suggested prompt as well. This gives us the option at the top to select the model. And as I was saying earlier, I've been running multiple models locally offline on my particular laptop here or my workstation. I have the Llama 3.1 with which I started initially, and then I added the Mistral and the Fee models. Now I can switch between these models. Let's start with Llama for a simple thing, and we can ask a question here in general way. Let's say, how is the weather in Melbourne in the month of October. October is coming, so let me just correct these typos here, and then let's put a question mark. I'll copy this question as well, and let's start interacting with the LLM. So here the output that we get is similar to what we saw on the terminal earlier using Llama 3.1. It tells us that Melbourne is the second largest city in Australia. It gives us this range, and this we already saw earlier in the previous video on the terminal. Now the advantage here is I can easily switch between these models, and I can ask the same question about the weather to Mistral model, and let's see what does Mistral give us. Now you see the output here is pretty concise as compared to that of Llama 3.1. And that's the beauty of these large language models. They are so much non-deterministic. If we ask the same question multiple times, we are not going to get the same answer. They are supposed to give us a different answer, just like a human would give a different answer if we ask the same question at different points in time. So clearly, Mistral gives a very concise answer, I would say just like one paragraph as compared to that of Llama 3.1, which gives almost 2 to 3 paragraphs. Now let's see Phi3, what does it do? I'm asking the same question, how is the weather in Melbourne? And Phi3 model again is somewhere in between that of Mistral and Llama. It's not as long as Llama 3.1, but it's also not as short as the Mistral model. So I think this is a very handy way of interacting and testing the different models that we have or that we are running on our computer. The other benefit of this is we have all these control settings. We can control how different parameters they control the output of the large language model. And one thing which is quite common with large language models is the system prompt. This is a way in which we can influence how the large language model reacts to our question. So I can say that for this particular use case, you are let's say well-known physicist or scientist, and answer all the questions as if, let's take Albert Einstein for example, is answering. Now imagine what would happen if Albert Einstein were to answer some of these questions that we are asking to the model. So let's first start by asking this same question to Llama 3.1, and let me close this setting here. Now I'm asking this same question, how is the weather in Melbourne? And the answer that you get, you see, is different. The weather in Melbourne, my dear fellow, is quite pleasant in October. The temperature, as I'm sure you are aware, is a crucial aspect of any weather phenomena, and it's giving the answer as if let's say Albert Einstein is answering this. Is this really the case? Let's see how does Mistral behave in this case. So if we ask this question as novice to Albert Einstein and Mistral large language model were to answer that, clearly we see there is a difference again. It starts with a different sentence. As a humble servant of knowledge and truth, I must admit that while I have dabbled in theoretical physics, my expertise does not extend to meteorology. And then it goes on to give various other details. Let's give a final try with Phi model. Now the prompt is same and the question is same about the weather in Melbourne, but again the system this time, or the system prompt, is answering as if it is Albert Einstein. And this time we see that among all the three models, Phi model is the one which is giving one of the most lengthiest answer. There are various other parameters here as well. We can control the seed parameter, the stop sequence, the temperature, which decides the tone of the answer, then the top, the frequency for repeat penalty or repeating the words, and all these different parameters related to the Ollama can be modified or can be updated using this user interface, which is the OpenWeb UI. I hope you found this useful, where instead of interacting with the large language model using the terminal or the API calls, you have this user interface, which is quite similar to that of the ChatGPT. And the ChatGPT model or the OpenAI API specifications is what other models, open source models, are also following in terms of the chat and the completions API. That is why this particular user interface is able to interface with all those OpenAPI compliant models. With that, I think I got a fair bit of understanding of how these models work and what parameters can be changed. If you want to try this out, it's a very simple command. I will put the command in the description and in the comment as well, how to get started with this using Docker Desktop. You also have the option of running this in other ways. If you don't want to use Docker Desktop, then you can go to the OpenWebUI portal or the website, and in here you can find the manual installation method. But I think the best way is to get started with Docker Desktop. With that, we come to the end of this video. I hope you found this useful. As a next step, do try it out and let me know in the comments what other things you found useful from the OpenWebUI. Thanks for watching this. I'll see you in the next one. Do hit the like button if you find this video useful and subscribe to my channel. Thanks for watching.